Hello and welcome to my new podcast, Air and Space Stories. Are you ready for an exciting news? Fasten your seatbelts and enjoy your flight with me, Cinzia. This is episode 8, season 1. 5G, welcome on board. Last December, when we heard the breakout news reporting that EU authorized the use of 5G in-flight connection during commercial flights, everybody got surprised. We will soon kiss flight mode goodbye? Not really. Some questions remain open. I will explain everything in this super interesting episode. On board a commercial flight, mobile phones, let's say smartphones, shall be in flight mode. No internet connection, neither Wi-Fi, no cellular. However, since 2008, some airlines offer mid-air internet access to clients who want to buy the service. This allowed them to exchange messages, write emails, watch short videos, etc. during flight. Nevertheless, in-flight Wi-Fi has been historically slow as it is relied on air-to-ground connection or to satellites. The first works exactly like the cellular network. Aircraft receive the signals through a dedicated antenna on ground and provide Wi-Fi connection by means of router. The second operates through signals coming from satellites. Useless to say that when the aircraft is flying above the sea, only the second solution will provide constant connection. Finally, in-flight connection has always been very expensive if compared to the same service on ground. Governments have been studying for some years a safe way to exploit the 5G technology that will allow people to stay connected during flights and, above all, to receive a better service at a lower price. The use of smartphones during flight is currently regulated in Europe by the European Union Aviation Safety Agency (EASA) and the European Commission, while in USA by the Federal Aviation Administration, the FAA, and the Federal Communications Commission, the FCC. Generally, the use of electronic devices such as smartphones is forbidden during takeoff and landing due to safety concerns, but can be used in airplane mode during the cruising phase of a flight. First thing first, what is 5G? 5G or fifth generation wireless technology is the latest and most advanced iteration of cellular network technology. It offers faster speeds, lower latency, and greater capacity than its predecessor like 4G and 3G. With 5G, users could expect faster download and upload speeds, better performance in crowded areas, improved reliability, and more stable connections. Additionally, 5G supports a wider range of devices and applications, including the Internet of Things, the IoTs, autonomous vehicles, and virtual reality. It achieves these improvements using advanced wireless technologies such as millimeter waves, small cells, and massive MIMO, multiple input, multiple output antennas. 5G is based on the use of high frequencies, up to 300 GHz, which allow more data to be transmitted in less time, which means higher speed, with a latency less than 1 millisecond. 5G also uses a technology called slicing, which can create independent virtual subnets for each type of service, thus optimizing the use of network resources, which means less use energy. 5G requires great antenna density and fiber optic coverage to ensure good signal quality. At the same time, being based on a decentralized network of antennas and cells ensures greater coverage and less interference. However, 5G infrastructures have not yet achieved the same level of coverage as 4G, since networks are currently limited to selected cities and towns. Rural areas, for example, now rely on alternative solutions like Elon Musk's Starlink. Delays are related not only to the implementation of the network itself, but also to the environmental impact. There is no clear evidence that 5G isn't dangerous. Even though it's currently not possible to use 5G flight connection on commercial flights, as most airlines still rely on ground-based wireless networks, some companies are exploring the use of satellite-based 5G networks. Additionally, some airlines are beginning to offer 5G connectivity on the ground, such as in airport lounges or in-flight line, which could eventually extend to in-flight use. It's important to note that there are technical and regulatory challenges to providing in-flight 5G connectivity, and it may be some time before it becomes widely available. Discussions and debate about the implementation of 5G technology on board commercial flights are currently ongoing. Some experts argue that 5G could potentially interfere with the aircraft's sensitive instruments and navigation systems, causing safety issues. On the other hand, 5G on board could provide faster and more reliable in-flight connectivity for passengers, leading to a better overall travel experience. Moreover, 5G technology can enhance existing applications such as passenger processing, baggage management, and airport operations, as well as enabling the new technologies such as edge computing, IoT, and digital twin. The introduction of 5G is good news for airports. In fact, while 4G can manage 10,000 devices per square kilometer, 5G can deal with 1 million with greater speeds and increased data transfer. This means airports can operate better systems and offer passengers a slicker experience that is not possible today. Nevertheless, 5G has some risks. The RTCA, the Radio Technical Commission for Aeronautics, a non-profit organization in the United States that provides technical guidance and expertise on radio communication systems and technologies for the aviation industry, published the results of a case study made by FCC and FAA in 2020 over the 3.7-3.98 GHz band. For Category 1, which is commercial airplanes used for passengers, travel and cargo transport, the results show a limited number of 5G scenarios involved, but extreme impact on aircraft. Which means that although the interference impacts only arise in a set of specific scenarios, some base stations configuration only were above the safe limit, and only for certain combinations of aircraft altitude and lateral distance between the aircraft and the base station, the extent and safety consequences of those impacts were extreme. Unreliable radar altimeter signals delivered to the critical aircraft systems like the autopilot, the flight controls, the terrain avoidance, and cockpit displays. And the catastrophic impact with the ground leading to multiple fatalities is possible. This is a huge discovery, actually. And for general aviation, including transport and helicopters, which are Category 2 and 3, the results show a huge amount of scenarios involved. That's to say, every base station configuration produces harmful interference, both from 5G fundamental emission in that band of study and in spurious emission. And the 5G user equipment, like the smartphones, operating on board aircraft exceed the safe interference limits with the same potential risk as said above. The FAA and the FCC are currently working together to assess the potential risks and benefits of the 5G on board commercial flights. In January 2022, the FCC approved the use of a portion of the 5G spectrum for commercial use, with the condition that a buffer zone was established around airports to mitigate potential interference with the avionics and aviation systems. According to U.S. agency, since the 5G technologies operates in a higher frequency band than previous cellular network technologies, it can potentially interfere with certain onboard systems of aircraft and other vehicles. Specifically, the concern is that 5G signals in the millimeter wave frequency range, typically above 24 GHz, could interfere with radio and radar altimeters, which are used to measure the altitude above ground level and provide the information to pilots or the autopilot, as previously said. If the 5G signal is too strong, it could potentially overwhelm the altimeter signal and cause inaccurate altitude readings. This could potentially lead to safety issues during takeoff, landing, and other critical phases of flight. Altimeters provide data also to engines and braking systems, for example, which allow the transition to landing mode. Some experts are concerned that interference could prevent the aircraft from stopping correctly. Moreover, both on commercial and general aviation aircraft, radar altimeters provide critical inputs to a wide range of aircraft systems and functions. As we said, the terrain awareness warning system, the auto land, a fully automatic landing, wind shear surveillance, the TCAS, the traffic collision avoidance system. So far, regulatory authorities in the United States and Europe have placed restrictions on the use of certain 5G frequencies near airports and other sensitive locations. Additionally, aircraft manufacturers and avionics suppliers are developing new altimeter technologies that are less susceptible to interference from 5G signals. Here you are some proposed solutions. The first is the installation of passive filter e-radar altimeters that will eliminate interference by reducing the bandwidth. This type of solution has the advantage of being easy to install and maximizing gain and signal level in distribution. However, it requires updating the technical characteristics of the existing filters and defining standard parameters for already operating radar altimeters. The second is the reduction of the power of 5G signals in the proximity of airports. This means that telephone companies offering 5G service must limit the intensity of their transmissions near runways. This type of solution has the advantage of reducing the risk of interference with radio altimeters without compromising the quality of the 5G signal. However, it requires cooperation between the authorities. And finally, the adoption of a next-generation UHF ground antennas, limiting reception only on TV frequencies. The antenna will be designed to be tuned to the protected band and to attenuate the potential interfering signals of 5G. However, it requires the replacement of the existing antennas and the choice among several available technology and models. If the risks are so important, why the EU Commission has announced that 5G in-flight connection will be available soon? It seems that in Europe we are luckier, since the 5G service is not too close to the spectrum used by radar altimeters. Airplanes could not face the same risk as in US. Moreover, 5G connection will be possible thanks to a technology called Mobile Communications on Board Aircraft, the MCA, which is a technology that allows mobile devices to be connected to mobile network with an antenna installed on the aircraft and a satellite connection. In this way, the signal does not interfere with navigation systems, and 5G can be enjoyed even in flight. MCA technology has already been used for previous frequencies, but now it will adapt it to 5G. That's the reason why the European Commission ruled to allow 5G on commercial flights starting from 2023. Notice that it will be up to individual airlines to decide whether they want to implement this technology. However, to use in-flight 5G connection, some important steps shall be made, such as update the execution decision on spectrum for mobile communications on board aircraft by designating certain frequencies for 5G technology, then equip aircraft with 5G compatible MCA technology, and finally ensure the safety and reliability of the 5G connection without interference with navigation and air traffic control systems. The conclusions are, promising because the traveling public wants the 5G. Governments are opening that possibility, but steps, as I said, shall be taken to ensure that whatever they do is safe. Aviation industry is proposing mitigation actions to help protect radar altimeters, implementing some mitigations. I am sure that one day we will be able to use our personal devices on board with at least less restrictions at lower costs. Maybe an alternative solution is already available for the USA, and most probably it will be extended to the rest of the world as well. In fact, last June, the FCC authorized SpaceX to use its Starlink satellite internet network with moving vehicles. Green light for Elon Musk's company's plan to expand broadband offerings to commercial airlines, merchant ships and trucks. Nevertheless, before using this new technology, must check complete the satellite configuration. I am aware that this episode was a lot specific. However, I hope you were able to get the general idea, the risks and solutions that will allow us to stay connected during flights very soon. Thank you for flying with me again. Hope you had a pleasant flight and look forward to seeing you on the next one. Bye bye from Cinzia.